Alright, so I'm going to start section 13.5 here a little bit. So think about a line in two dimensions. When you have the equation of a line in two dimensions, you need to know a couple things. You have to know like a slope, like which direction it's going, and you need to know like a point on the line to kind of like ground it, right? And so you need similar information when you're doing something in three dimensions. So you need basically a point and a slope. So in 3D, instead of talking about a slope, we need a point, and we need a direction vector, because the direction vector is going to tell us which direction we're going, or which kind of angle it goes to. Okay, so a point on is going to be this one, x1, y1, and z1. And the direction vector is going to be a vector and have the letters A, B, and C. So when I use these things down below, that's what we're going to have. So when you have an equation in 3D, there's different ways that you can write it. The first way is parametric. So you might notice this from like physics or some science classes. Parametric is when something is split into like X, Y, and Z. Like you have an X motion, a Y motion, and a Z motion. So if you want that, and this is actually kind of like the one that's kind of the most useful. So it goes X equals, Y equals, Z equals, and it goes like this. You take your point, and then you add with AT, and then you take Y1 plus BT, and you take Z1 plus CT. So you have your point there, and this could go in back as well. But notice that what's happening here, it's kind of like y equals mx plus b in a way, because your slope is going with your variable, right? And we're using a letter t because a lot of times we're talking about time or something like that. So anyway, this is a equation of a parametric equation of a line. It's those three equations together. So then you have what's called a symmetric form. Okay, so the symmetric form, you notice all of these things, they can be solved for t, right? So if I solve this for t, it would be x minus x1 divided by a. And that should be equal to this one solved for t, which is y minus y1 divided by b, which is equal to the last one, z minus z1 divided by c. So in a way, you know, make a note to yourself, these are all equal to t, right? But that's another format. So if you see something in this format, you can pick out the direction vector at the bottom, and then the numbers behind here are is a point, and so forth. All right, and the last one is if sometimes it's in vector form. So you won't see these that much, but you might see it like this. You'll see a line equal to, and then you might have your point here, x1, y1, and z1, plus, and then you have a vector a, b, c next to the letter t. So you might see it written like that. Or another way you can see it is maybe you have L equals 2, and you see it like this. Like for example, I'm going to do an example. Like let's say this right here is a coordinate, so that you would write like 2i plus 3j, how about minus k, plus, and then with parentheses, with the t over here, you have another vector that's your direction vector. Let's say it was like I minus j plus 2k. Right? So again, this would be your point vector in a way, and then this, or just your point, and then this would be your direction. Okay? So the one that I would choose to use, if I could the most, I would use this one right here. And symmetric is a close second to that. Vector, not that much, but sometimes. Okay, so let's do it right here. So find the parametric and symmetric equations for a line L that passes through this point and parallel to this vector. So parallel to that vector means that's its direction. So here's that vector, 2, 4, negative 4, and I want my line to go through this point right here. So I basically want something parallel to this going through that point. So that's what that picture is showing you right there. Okay, so we will write the parametric format. X equals, Y equals, and Z equals. So I will take 1 for my point plus 2t for my direction. I'll take negative 2 plus 4t, and then take 4 plus, oh darn it, that should be minus 4t. So I'll just put negative 4t, but you know, I'm writing in pen, but anyway, that should just be a minus right there. Okay, and my symmetric form. So once I have this, I could kind of like solve it for t in my head. So x minus 1 all over 2 equals y plus 2 over 4 equals z minus 4 over negative 4. Okay. All right. So down here, find a set of parametric equations for the vector equation of the line that passes through these points. So we are going to find the vector between these 2 points for the direction. So my direction vector is going to be, I'm just doing it backwards, like this is the beginning, that's the end. It actually doesn't matter. So 5 minus negative 2 is 7. 2 minus 4 is negative 2. Negative 3 minus 1 is negative 4. So there's a direction vector, and it also could be the opposite. Or you could do a parallel vector to this, but why would you bother? And now this is the part where it gets annoying, and where in the back of the book, if you look at an answer, I mean, you could use this point, and maybe I use that one. So like, you know, you're both right, it's just you're not going to notice it. So we're going to do parametric equations. So this is my line right here. I guess line L, all right. X equals, I'm going to use this point right here. So I'm going to do negative 2 plus 7t. Y equals 4 minus 2t, and z equals 1 minus 4t. Okay, so there's a parametric equation of that line. So these numbers could be replaced with these. That'd be fine. So at what point does the line intersect the YZ plane? So think about on the YZ plane. When you're on the YZ plane, ask yourself, what letter is equal to 0? So if you're on the YZ plane, so if you're on this plane that is at the Y and the Z plane, that means you haven't gone out on the x-axis. So anything on the YZ plane, the x value would equal 0. So I'm going to steal this up here, and I need to ask myself, this has to equal 0. The x value has to equal 0. So what I would do is take negative 2 plus 7t, set it equal to 0. You solve that, you'll get 2/7. So t is 2/7. So I'm going to plug that back into my equation here to get a point on my line. So my x value, I know if I plug 2/7 back in here, that was the whole point, it's going to be 0. It's going to be negative 2 plus 2. All right, if I plug 2/7 in here, I could have made this easier on myself. So it'll be 4 minus 2 times 2/7. So 4 minus 4/7. So 4 is 28/7 minus 4/7. So that's 24/7. All right, and the last one, 1 minus 4 times 2/7. So it's going to be 1 minus 8/7. So that's 7/7 minus 8/7. So that's a negative 1/7. Okay, so there's that point. The point where it intersects, where the x value is 0, so it's on the YZ plane. All right, and then my question here, is that line up here parallel to this? So I have to check and see if the direction vector is parallel to the direction vector of this new one. Now, I did something here with this guy. Do you notice? Do you notice that this is backwards? So it's very important to have it in the proper form if you're going to see what the direction vector is right here. So I have to switch that around. So if I reverse 6 minus x to x minus 6, like I know it should be, then I'm going to have to put a negative 7. Because it's like I multiply the top and bottom by negative 1. So if you want to reverse the order to make it more like what you want it, like what you need it to be to see everything, then you need to apply that to the bottom too. So equals y plus 3 over 2 equals z minus 4 over 4. So if you have that in the proper format, then this right here will be your direction vector, negative 7, 2, and 4. So negative 7, 2, and 4. Is that, this is my direction, is that parallel to 7, negative 2, negative 4? And yes, it is, because it's just a multiple of negative 1. Okay, so I would say yes to that. All right, so let's see what we can finish up here in the next couple minutes on the next page. All right, so I think what we'll do is we will just get through like this. Just do this example. All right. So what happens when two lines intersect? So like in 2 dimensions, all right, you have x and you have y. You have one line, you have another line. When 2 lines intersect, that means their x value and their y value, they match at that place, right? So I have two lines right here. One of them is parametric form, one of them is in symmetric form. So if something's in symmetric form, I usually right away write it in parametric form, because this way it kind of stinks. All right, so I do notice a little trick right here. So that should be y minus 5 over positive 2. All right, so x minus 7 over 5 equals z plus 8 over 3. So we cannot use t again when I'm writing this in parametric form, but why don't we use like u or something like that? Because I already used t, and I can't use the same letter in the problem because I can't repeat myself. So I'm going to say x equals, so I'm going to say 5u plus 7, and 7, and y equals, so that's going to be 2u plus 5. So what I'm doing is I'm taking, remember how before they were all equal to t? Well, now they're all equal to u. So y minus 5 over 2 equals u. I get 2u plus 5. And then z equals 3u minus 8. Okay, so there's my equation in parametric form. That's the most useful. So these things are supposed to line up, right? So at some point, this is supposed to equal that, and this is supposed to equal that, and this is supposed to equal that. Okay, so I have to find the t and the u that make that true. So when I do that, I'm going to have to basically solve a system of equations. I have 3 equations and I have 2 variables. So I only really need 2 of the equations. So I think I'm going to just take let's see, 2, these are all gross. I'm just going to take like the top 2, the x and the y. So I take 6 plus t has to equal 5u plus 7. And negative 5 minus 2t has to equal 2u plus 5. So remember, when you solve a system of equations, you can get the variables on one side and the numbers on the other, but why don't we just work with it the way it is here? I have to get one of these letters to cancel. So I'm going to multiply the top row by 2, so I can get that to be a 2 right there. So it's going to become 12 plus 2t equals 10u plus 14. Negative 5 minus 2t equals 2u plus 5. So then we're going to add them together. So that cancels. I get 7 equals 12u plus 19. And so I get negative 12 equals 12u. That means that u is negative 1. Okay. All right. And so now that u is negative 1, I take either of those 2 problems and I'll figure out what t is. So I think I'll just take this one. If u is negative 1, so I get negative 5 minus 2t equals negative 2 plus 5. So that's 3 equals negative 5 minus 2t. So it's 8. So negative 4. Okay, so the thing is, line 1 and line 2, I go and find that point. So when u is negative 1 and t is negative 4. So this one is using t. So I'll be using t is negative 4. So 6 plus negative 4 is 2. Negative 5, that'll be plus 8, so that'll be 3. And then negative 4, so it'll be 1 minus 12, that'll be negative 11. So here's the thing. I know that the 2 and the 3 are going to match because I solved a system of equations with these items. It's the last one that's going to tell me if they actually do intersect, and so I'll get the same answer. So let's try it. So I'm using u is negative 1. So put negative 1 in here, I get 2. Put negative 1 in here, I get 3. Those are supposed to match because that's what I just solved. And then the last one, I put negative 1, so it'll be negative 3 minus 8. And there it is, negative 11. And so what will happen if the third one that you didn't use doesn't match, then you have what are called skew lines. So skew lines are lines on different planes or on parallel planes. Okay, so what 2 situations lines don't intersect? They would be skew, or the lines basically are parallel. And I'll show you in class what I mean by skew. It's like if you have lines that are on like different planes, they're on parallel planes, but they can go different directions and so forth. Okay, all right, that's it. I'll see you in class. Bye-bye.